We are going to pick up on page 22, and we're going to continue talking about normal distribution. So last time we talked about a few examples of normal distribution, normally distributed sets. We're going to look at another normally distributed set to start for today. Example 4 on page 22 says that the mean battery life of a fully charged cell phone is 14 hours with a standard deviation of 1 hour. Draw a normal curve to represent this. So we did this last time. Get my x-axis in there, draw my curve. I know my mean is under the highest part, and it says my mean cell phone life is 14 hours. So the calculated average for these cell phone batteries is 14 hours. And then remember, we split our curve on either side. These should, again, be roughly evenly spaced. And then our standard deviation is 1 hour. So 15, 16, 17, and then 13, 12, 11. Okay, there's our curve. What's the probability that a phone battery will last at least 13 hours? So that means 13 hours or longer. Now, I know the section from 13 to 14 hours is 34%, right? 13 to 14 hours is 34%. And that is way back from page 20 when we labeled our normal distribution curve with all these percentages. And then 14 or greater is half my curve. So 34% plus 50% would give me 84%, or 0.84 since we're looking at a probability. Okay, so there's a pretty good chance that my cell phone battery should last at least 13 hours. C, what's the probability that a phone battery will last less than 12 hours? So 12 or less. So I'm looking at the chunk between 11 and 12. Okay, down here. This is 2 standard deviations below. This is 3 standard deviations below. Again, I can flip back in my notes and see that that's a 2.5% chance. Or if I want to, I can write that probability as a decimal, just like we did earlier this unit. It should make sense that there's a big chance that I last at least 13 hours. If I thought about shading the portion of this curve that I'm looking at, that's a lot of the curve. That's more than half of it. It should make sense that this is also a small probability, less than 12 hours. Is that little piece right there? That's a small amount of that curve. D, what's the probability that a phone battery lasts between 14 and 16 hours? So 14 to 16 hours, this chunk right in here. So I know this section is 34%. And then my next section between 15 and 16 is 13.5%. So I would get 47.5% when I add those pieces together. Or again, since we're talking about probability, 0.475. Now let's take this information and apply it to a sample set. So if we test 500 phones, how many would we expect to have a battery life between 14 and 16 hours? Well, I know the probability that I have a battery life between 14 and 16 hours is 0.475. So if I test 500 phones, I want to find 47.5% of them. That's how many I would expect to be there. So this gives me 237.5 phones. Since that last phone didn't make it all the way there, I'm going to say this is 237 phones. Okay. If I test 500 phones, I would expect about 237 of them to have a battery life between 14 and 16 hours. And now F, what is the probability that a phone battery will last between 14 and 14.5 hours? So this one's kind of tricky because 14 is our mean right here, but 14.5 is right here. It's not 34%. 34% is this whole section, this whole first chunk up to that first standard deviation above. But it's also not going to be half of 34 because my curve is not a perfect rectangle. If it was a perfect rectangle, I could just cut that in half. But it's not a perfect rectangle. I actually have a little more data in this first portion of this curve, in this first half a standard deviation than I do in this second half of the standard deviation. So what's that probability? Based on the information that we have right now, we don't know because again, this is not a full standard deviation. It doesn't even matter if it's above, we'll just say from the mean. And it also doesn't matter that we're measuring from the mean. If I asked you what's the probability that we're between 15.5 and 16 hours of battery life, right? This section right here, I can't answer that question right now either. But that's still an important question to be able to ask. So when we want to find a probability associated with some number that's not a whole amount of standard deviations from the mean, what we're going to use is something called a z-score. Okay, so the z-score tells us how many standard deviations from the mean a given value is. What we're going to do with our z-scores is essentially kind of ignore the actual values that we're looking at here. We're going to focus for these last few questions, not so much on, as we're measuring and finding these probabilities, we're going to focus not so much on 14 to 15 hours or 15 to 16 hours or 14 to 14.5 hours, but we're going to focus on what's my difference from the mean? How many standard deviations from the mean am I? Okay, and that's the lens that we're going to look at. We're going to look through with our z-scores. So for z-scores, I am going to put my mean as 0. 1 or plus 1 means I'm 1 standard deviation above the mean. 2 or plus 2, you'll also see this as, is 2 standard deviations above the mean. 3 or plus 3 is 3 standard deviations above the mean. And then minus 1 means 1 standard deviation below the mean. Minus 2 is 2 standard deviations below the mean. Minus 3 is 3 standard deviations below the mean. So essentially what we're doing is we're taking the same curve, but instead of actually filling in what's our mean battery life for the cell phone and what battery life is 1 standard deviation, how many hours would be 1 standard deviation or 2 standard deviations below, we're just going to use 0 plus 1 minus 1 plus 2 minus 2 and so on to be able to sort of stand in for those values. So we're counting standard deviations from the mean instead of counting hours of battery life for that cell phone example. Because we're still looking at the same spread, we're still looking at a normal distribution, all these percentages are the same. That hasn't changed. Just the lens that we're using is a little bit different. Okay, so again, the key idea here with z-scores is that minus 1 refers to a score that is 1 standard deviation below the mean. So if you see minus 1 in reference to a z-score, we're talking 1 standard deviation below the mean. If you were to see plus 2.5, that means we're looking at a score that is 2.5 standard deviations above the mean. And you'll see some example problems that use that terminology a little bit later on. Now, how does this help us for problems like F here when I'm not dealing with full standard deviations? This is where we're going to pull out our calculator because our calculator can actually use those z-scores to be able to do this interpreting for us. So on the next page, on page 23, up at the very top are your calculator definitions. As we're going through some of these problems on our calculator, I want to point out that this is not a mystery or like a big secret. Your calculator isn't trying to be tricky with the menu keys. So if you get stuck, it's okay to click into a menu and realize that wasn't the right one and go back. And I also want you to think about what our goal is here. What are we trying to do? Because that helps us a lot with figuring out which menus I need to navigate through. I know for a lot of us, getting through the calculator menus is the tricky part. Just remember what it is that you're trying to do. So we're going to use these calculator steps and just do a practice problem here. So I want to find the probability that a score falls between a mean of 0 and 0.25 when the data has a standard deviation of 1. So here are the important things I need. I need to know the mean. I need to know the standard deviation. And I need to know my lower value and my upper value. My lower value is 0. My upper value is 0.25. It says I want to find the probability that I'm between 0 and 0.25. So 0 is my lower value, 0.25 is my upper value, okay? The 0 value is also my mean for this problem. That's okay. So let me pull up my calculator here, and I'm following the directions at the top of page 23. So I'm going to go to a list and spreadsheet page. And then in a blank cell in an unlabeled column, so right here works since this is a brand new document, I'm going to go to menu. Okay, anything I want that's not a key on the calculator probably lives in menu. And then I'm going to go to statistics. We're in our statistics unit, so I probably want the statistics menu. Okay, I'm looking at information from a normal distribution, so I'm going to go down to distributions. And then here's the only part where this is a little tricky. You've got two options for normal. We're going to use CDF, okay, normal CDF. I get this little box that pops up, and notice there's a spot for all of those little important pieces that I jotted down. So my lower value for this particular problem we said was 0. So I'm going to type 0, and then I'm going to hit the tab key to get down to the next box. My upper value was 0.25, so I'm going to type in 0.25. And then tab down to the next box. My mean is 0. That's the default here. My standard deviation is 1. That's also the default here. So I'm going to go ahead and click OK. There we go. And that is my probability. So my probability here is 0.099. We'll round to 3 decimal places. 0.099. Okay. Okay. So all of that information that I pulled from the problem, I just typed in that box. Now, I do want to show you one more thing here. I'm going to go ahead and go back to my calculator page. I'm just going to do a new document really quickly. And I'm going to do that same thing, add list and spreadsheet. I'm going to do the exact same problem, but I want to show you something else that we can get here. So distributions, normal CDF, my lower bound was 0, my upper bound was 0.25. Mean, standard deviation stay the same. If I click this little box, and this is only an option in the spreadsheet, but if I click this little box to shade area, what it does is give me a little picture of what I'm looking at, which is nice, especially as we're starting off, to make sure that I'm entering appropriate numbers. So I know my mean is 0, my standard deviation was 1, and I'm looking at percent or probability that a value falls between 0 and 0.25. That's a very thin little strip just ahead of the mean. And so this shows me that picture here. Okay, so just an option. I'm not going to have it sketch for our next few problems, but it is a good way to be able to double check that you're entering the information that you want to enter. So let's go back to our notes here. And for the last few examples, we're going to do the same thing. Okay, use our calculators to help us with these calculations when I'm looking at finding probabilities that data falls between numbers that are maybe not exactly 1 or 2 or 3 standard deviations from the mean. So example 5, for a normally distributed curve, the mean is 100, and I like to jot these things down off to the side. Makes it a little easier when I go to type it in my calculator. The standard deviation is 15. Find the probability that a randomly selected item of data falls between 100 and 120. So my low value is 100. My upper value is 120. Now I'm going to sketch this one out. And let's think about this for just a second. So my mean is 100. My standard deviation is 15. So this would be 115. This would be 130. And then up here, 145, the top half of that curve. So I'm looking at a data value that falls between 100 and 120, which would be somewhere in here, a little bit closer to the 115 mark, not halfway through. So between 100 and 120. I'm looking for the probability that I pick something in this range. I know it should be more than 34% because between here and here is 34% of my data. So it should be more than 34%, but it's not up to that next standard deviation. So it's got to be less than that 47.5 that we've seen from some of our other problems. So I'm going to pull my calculator up here. I'm going to go into a new blank space, menu, statistics, distributions, normal CDF, and I'm going to enter that information. So my lower bound is 100. My upper bound is 120. This time my mean is 100 and my standard deviation is 15. Okay, there's my probability, 0.409 if we round to 3 decimal places here. Okay, which we said this should be more than 34%, less than 47.5, and that's what we get here, 40.9 as our probability. Example 6, we're going to use this same population and distribution from example 5. So we know our mean is 100. We know our standard deviation is 15. What's the probability that I randomly select an item that is less than 110? So this time, they actually didn't give me my lower bound. They gave me an upper bound. I want less than 110. So 110 is my upper bound here. If you're not given a lower bound, I want you to keep the calculator default. It is plenty small enough for everything that we're going to see in Algebra 2. So we'll keep the calculator default there. So again, I'm going to pull my calculator up and I'm just going to go to a new space, menu, statistics, distributions, normal CDF is what I want here. I'm going to keep the lower bound for my calculator. So I'm just going to hit the tab key. My upper bound is 110. My mean is 100. And my standard deviation is 15. Okay, so I get 0.748 if I round to 3 decimal places. And let's think about this for just a second. If I come back to my curve here, I want less than 110, the probability that I'm less than 110. So 110 would be like right in here. Everything less than that is all this stuff. So I know it's more than half of my data, okay? It's not up to that first standard deviation yet. So it's got to be less than 50 plus 34, okay? Which is what I see here. You should always be able to decide if your probability actually makes sense based on what we know about how that curve is sort of sectioned out. For example 7, we're using the same population again. This time I want to know what's the probability that a randomly selected item is greater than 120. So same mean of 100, same standard deviation of 15. My lower bounds this time, I know. I want my item to be greater than 120. So I'm going to set 120 as the bottom. And then my upper is the thing that they didn't directly give me, okay? So anytime I have to set an upper bound, I have to make that decision myself. I want to make sure I pick an upper bound that's high enough so I definitely cover 3 standard deviations from the mean. I don't want to accidentally cut it off here because then I haven't included all these other pieces of data that I could potentially very reasonably have. So I always make sure I set my upper bound, set at least 3 standard deviations, at least 3 above the mean. Now, you don't need to actually calculate what that number is. Our mean is 100, our standard deviation is 15. So pick something way bigger than 100, okay? Our standard deviation is 15, so I don't want to pick 7, like 107 is my upper bound. That's not big enough. I want to pick something crazy big. I always err on the side of way too large. Way too large is better than way too small. So if my mean is 100 and my standard deviation is 15, maybe we can pick 200. Or maybe we pick 1,000. I pick something that's sort of obnoxiously big. That way I make sure I don't accidentally cut off a piece of my data. Let's pull our calculator back up here. Again, new space, menu, statistics, distributions, normal CDF. My lower bound this time is 120. My upper bound I get to pick, and I'm going to set it at 1,000. That is plenty big enough. My mean is 100, and my standard deviation is 15. So I get 0.091 if we round to 3 decimal places. So what's the probability that I'm greater than 120? About 9%. There's about a 9% chance. And again, if I look at my data, bigger than 120, here's 120, I'm looking at bigger than here, okay? This chunk is 2.5. This whole chunk is 13.5, but I don't get the whole chunk between 115 and 130. I just get this part of it. Okay, one last example for today. Example 7, you have a normally distributed curve with a mean of 52 and a standard deviation of 3.157. What is the probability that a randomly selected item is between 49 and 56? Now you'll notice on this one, based on our mean and our standard deviation, neither of these numbers should fall right on any standard deviation lines. That's okay. My lower bound is 49. My upper bound is 56. That's the nice thing about the calculator, is that it can figure this out for me. Okay, even though we're not on any nice standard deviation lines for this problem. So again, I'm just going to hop down another space. And menu, statistics, distributions. And again, I want that normal CDF. So my lower bound here is 49. My upper bound is 56. My mean is 52. And my standard deviation is 3.157. And I get 0.726. Okay. 0.726 there. So my mean is 52, standard deviation of a little over 3. What's the probability I'm between 49 and 56? Not quite a 3/4 chance. Okay, so that's finding those normal distribution probabilities using our calculators, using your TI Inspire.